Hello everyone, my name is George. I'm a security analyst here at LBridges, and today I'd like to welcome you to our YouTube page. LBridges is a cybersecurity company based in Thika, Kenya, and we offer services in the cybersecurity space. We do vulnerability assessments and penetration testing services. We also do incident response and digital forensics. We also offer cybersecurity as a managed service to organizations that may not have the capacity to have a full-blown security operations center for monitoring of the security needs. And apart from that, we are also ISO 2007 certified, meaning that for all the services that we offer, we are also audited to ensure that we keep up with the recommended industry standards. I'd highly encourage you to head over to our website, that is www.lbridges.co.ke, and have a look at some of the services that we offer, some of the products that we do offer, and also some of the clients that we've worked so far. I'd also encourage you to consider liking, sharing, and subscribing to this video for more of this content. So today we'll be looking at the Apache Log4j vulnerability that was discovered in late 2021. We're going to have a look at what exactly is Log4j, how does it affect organizations. We're going to create a proof of concept for that, and also we're going to have a look at what can organizations do to prevent against this vulnerability that was given a critical score of 10 out of 10. So without much further ado, let's head over to our lab and see what we can do with this. So maybe if you've never heard what Log4j, the Log4j vulnerability is all about, you don't know what the hullabaloo about it is all about. So Log4j in and of itself, it's a Java library framework that is used for logging. So when developers make applications, they have to make room for errors to occur, because nothing is ever perfect. So they have to make room for that. And mostly, not all applications, but most applications, they might be using the Log4j Java library to log the errors that may occur during the execution of that application. This library is used for troubleshooting purposes, right? So an error occurred, it threw an exception or something like that. The developer or someone who is responsible for that will have to go to the logs and have a look at whatever it is that occurred, and they can be able to troubleshoot that. So in a nutshell, the Log4j it's a logging framework. So in that case, maybe you might be wondering, then where does the vulnerability occur? The vulnerability occurs in unpatched Log4j Java libraries. So up until last year, early this year, most applications that were running this library were vulnerable to that, and up until now, still a lot of applications are still vulnerable to that, are still vulnerable to this. And the vulnerability occurs in that an attacker is able to send malicious code to the application that is running the vulnerable Java library, and they're able to run remote code execution against that application, and that could lead to a complete system takeover. They can also install backdoors on that system. They can do a whole lot of things on that application. So how do we mitigate against that? We mitigate against that by patching our systems, ensuring that our systems are patched. Since this vulnerability occurred in systems that were lower than 2.15.0, so patching our systems will ensure that our systems and our applications are no longer vulnerable to this vulnerability. If you're not able to patch our systems, another alternative will be to remove the GNDI lookup class from the log4 class. Remember that Java applications are usually made of different classes. So if you're able to remove this, the JNDI lookup class from the log4 Java class, we can be able to mitigate against this. So let's head over to our terminal to see how the POC for that works. So before recording this, there's I already went ahead and created the POC for this. So if you would like to follow along, I'm going to let me share the guide for us to do that, and you can be able to follow along. Alright, so the first step will be to set up a Netcat listener on our system. So I'm going to go to my terminal and I'm going to set up a Netcat listener, LDAP. So we set up a Netcat listener on our machine, and the next step will be to set up an LDAP server for us to generate the malicious code that we'll be sending to the application. So for us to do that, we'll copy this script, and what this is going to do is that it's going to set up the LDAP server, and it's going to generate the malicious script that we'll be sending to the vulnerable web application. So I'm going to have to Netcat listeners. So yes, so let's set up our LDAP server. So this is going to set up our LDAP server, and it's going to generate the malicious code, the malicious Java code that you're going to send to the vulnerable web application. So this could be the vulnerable application. Could be a web server, it could be an application, could be a service, could be anything that is running the vulnerable Log4j Java library. So it doesn't have to be a web application. If you look at our guide over here, it's up here. If you look at our guide over here, we can run this against Minecraft, which is a game. We can also run this against Gitra, which is a reverse engineering framework. So of course there's the patched version of Gitra. So to replicate this, we'd run this against the unpatched version, so the old Gitra version, right? And for this Gitra, if you know, Gitra it was developed by NSA. So imagine an application that has been developed by the NSA, and it's still vulnerable to was vulnerable to the Log4j vulnerability. It means that so many applications out there in the wild are still vulnerable. And we can also do that against a web application. And if you're able to do this against a web application, we can take over the whole web server. So the criticality of that it's enormous. As it was given a criticality of 10 out of 10, which is critical. It doesn't get any worse than that. 10 out of 10. Alright, so let me go back to my terminal and have a recap of what we've done. So over here we've set up a Netcat listener that will be listening for a callback on port 9001, and after doing that, we've created another terminal, and we've spawned up an LDAP server that is going to create for us a malicious code that we're going to be sending to the vulnerable web application. So essentially this is what an attacker will be doing, right? They create a malicious code and send it to the vulnerable service, application, or server that is running the vulnerable Log4j Java library, right? So if we have the LDAP server running, and the next thing will be to start a Docker instance. So let me go back to my guide over here, and I went ahead and did this because it took a little bit of time. So I thought I should go before you, save you a few minutes of time, and see how this goes. So I'm going to run my Docker instance and start my web application. So I'm just going to I need to run this as sudo, and then I'm going to paste that, then I'm going to we're going to start a Docker instance. So this is where the web application is running from, right? So you can think of this as a web application that is, it's in the wild. An attacker is out there, they found a web application, and it's, they've done their due diligence, and they've discovered it's running, the Apache version that is running is vulnerable to Log4j. So this is what they will do. And from our Docker instance, we're going to access that on our local host. Put 80. So let's run our web application. See how an attacker will go to do this. Alright, so our application is up and running, and let's go back to our terminal. So now this is the Java variable that contains the malicious code. So I'm just going to copy this up until there, copy all that, and send it to the web application. Yeah, so we can put this in any input field, the username or the password. Just paste it over here, and then I want us to check our Netcat listener for a callback for a connection. So minimize this, and go back to our listener. So we've supplied our malicious code over here, and let's see if you're going to get a callback on a Netcat listener. So I'm just to click on login, and let's wait and see. We have a connection to the web application. So what just happened is that we've sent this malicious code, and it's been executed on the web application, and we have a callback to our machine. So when I come back over here and we say ls, we can be able to list everything that is listed on that web application. So essentially these are the files that are contained on the web application. Imagine if this was a server, of an organization. We'd be able to see the database, able to see the users, be able to access the passwords. It gets crazy. Remote code execution is, it's really devastating when it happens. So that's it from me. Thank you so much for making it to the end of this video. If you found it informative, please consider giving it a like, a share, or even subscribing to our YouTube channel. If you'd like any of the cybersecurity services that we mentioned, you could call us on 0703 412 771. You could also write to us, office@tlbridges.com. You could visit us at T Plaza 4th floor, based in Thika, Kenya. Until next time, thank you so much.